So lastly, we're going to look at inverse functions as application questions. Inverse functions are going to be used a lot in life with conversions and other things, but we see them often in conversions, like when converting inches to centimeters and centimeters to inches. And this inverse function just shows a back and forth relationship. We start out with this vehicle stopping distance question. So taking into account the reaction time, the distance in feet that a car requires to complete stop while traveling X miles per hour is given by this function. Basically what we have is a function of f, or a function of x, and that x is representing our speed. So if we looked at what this mapping is meaning, we start out with our speed, and we're calculating our distance, our stopping distance. So x is being mapped to y, but x is representing our speed. By using this function f of x, we get our distance. So in this case, f of 50 is saying 6.79 times 50 minus 90.39. This is our input x, and we're trying to find our output y, our distance. If we plug this into our calculator and spit out our output, we get 249.11. So now this is showing the output, or the distance, is 249. In context, this means that if a car travels at 50 miles per hour, it has a stopping distance of 249.11 feet. Now B says f of x equals 350. So we don't know the input, but we do know the output is 350. If I plug that in, 350 for f of x, now we're solving for x. So I'd add 90 and get 440.39. And then we would divide, and you can use your calculator for that. So we divide both sides by 6.79 and get 64.86. So now 64.86 is representing x, which is our speed. So if the car had a stopping distance of 350 feet, then it was traveling at 64.86 miles per hour, or roughly 85 miles, or 65 miles per hour. Part C wants us to find the inverse function. So let's go back to that mapping, what we have here. Our current function f of x, we said, took speed to distance. So we use that function x, or f of x, that took speed to distance, and now we want to find the inverse which is taking our distance into our speed. So we're going to have an input now of distance, and that's what we saw when we were swapping our x's and y's earlier. So I'm going to go back and solve it the same way, but we're going to use some caution in trying to understand what this means. So we said f of x meant y. That was our output. Our goal is to find the inverse, which was a swap of our x and y's. So I'm going to do that part here. And if we solve for y, we would add 90, so x plus 90.39 equals 6.79y. Divide again, so y is x plus 90.39 divided by 6.79. And that's our inverse function. So we could write this in inverse notation that says f inverse of x is x plus 90.39 divided by 6.79. And that's an accurate function rule. We've got it. But the problem is we haven't interpreted now what this really means. And since we swapped, so since we switched our x and y's, the inverse of this, so the inverse f inverse of x now represents, I gotta write small, but x as our distance and y as our speed. And this holds a new thing because we swapped our x's and y's, so our distance became the new x's and the speed became the new output, which is our y's. So if we were just writing out what does this inverse mean, the inverse f inverse of x. All right, it just shows the function for speed if you're given the stopping distance. So that just helps about a little bit in context. We'll do one more, and I'm going to talk about the caution of what happens when you don't have these x's and y's, because the context of x doesn't mean a lot unless I just told you x meant speed or x meant distance. So when we have something with temperature and we're given this common formula for Fahrenheit, Fahrenheit equals 9/5 C plus 32. These C and F mean something to us. So let's look at the mapping for this one. All right, we have a mapping that says I'm going to take Celsius and convert it to Fahrenheit. So I'm getting this relationship, and we could write it as f of c because c is our input. If I'm finding the inverse function, all right, we're going backwards and finding what would be notated as f inverse of c. And so what we are saying here is that we need a function that takes our Fahrenheit now as our input back to Celsius. Okay, I'm going to do this two ways to kind of show what this means, but based off what we have here, F equals 9/5 C plus 32. I'm not going to swap our x's and y's here because these x's and y's truly do mean something. Our x is really a c for our input. So just go with me for the fact that I'm not swapping these for now, and then I'll explain what it means and why I'm not doing that. So I would subtract 32 from both sides. And then we're trying to do the inverse of multiplying by 9/5. So I can multiply by the reciprocal, which would be 5/9. And I get C. Remember, we wanted a function that took Fahrenheit back to Celsius. Well, that's what we just found. We found a function that takes Fahrenheit and converts it to Celsius. So F inverse of C is represented by c equals 5/9 f minus 32. And this is our inverse function. It's just not written like we have seen it. Okay? If I show you what it would look like swapping our x's and y's, all right, I'm just going to do it off here. We would have something that says f equals 9/5 c plus 32. And if I swap these, we would have 9/5 f plus 32. Subtract, so c minus 32, 9/5 f, 5/9 c minus 32 equals f. Well, that's not really going to help us out. And the reason that doesn't help us out is because of this mapping. Remember, the original function took Celsius to Fahrenheit. Okay, so if we went this way, we swapped our x's and y's, meaning you swapped the meaning of these things. Okay, so earlier in the original function, we could say f of c told us that c represented Celsius and f represented Fahrenheit. When you look at f inverse, if you're swapping your x's and y's, you're now saying that c stands for our Fahrenheit and f stands for our Celsius. That doesn't make much sense. So it's actually easier to just not swap them like I did in the first way, because that is showing the inverse relationship. Otherwise, you're going to have to explain what the new c and the new f mean, and that doesn't really make much sense. So if you're going to solve an inverse function with actual context and variables that are not x and y that mean something in context, then it's actually easier to not swap them and just show what that represents by writing the equation out this way.